How do you scale non-Newtonian fluid for industrial production? Imagine trying to pour ketchup that suddenly thickens or flows more easily depending on how you shake the bottle. That's a perfect example of non-Newtonian fluid behavior, which makes scaling these fluids for big factories quite a puzzle. Unlike regular liquids that flow the same way no matter what, non-Newtonian fluids change their viscosity when stressed or sheared. To produce these fluids in large amounts, engineers first need to understand how they behave under different conditions. They do this by testing the fluid's rheological properties using models like the Power Law, Herschel-Bulkley, Casson, or Bingham plastic. These models help predict how the fluid will act when stirred, pumped, or mixed, which is key for designing the right equipment. Once they know how the fluid responds, they can design pumps, mixers, and pipes that handle the changing viscosity and yield stress properly. For example, sure-thinning fluids like some paints or food products become less viscous when stirred, so pumps need to be powerful enough to handle that change without clogging. To keep everything running smoothly, real-time monitoring tools are installed directly in the production line. Devices like inline viscometers and density meters measure viscosity and density constantly, so operators can make quick adjustments. This helps maintain consistent quality and prevents surprises like sudden thickening or thinning during production. Scaling also involves careful process control. Adding powders or emulsifying ingredients can cause rapid changes in viscosity, so managing the order and method of adding materials is important. Mixing needs to be gentle enough to avoid sudden viscosity jumps that could clog pipes or slow down production. Material handling must also consider the fluid's behavior under different stresses to prevent blockages or inefficient flow. Did you know that some non-Newtonian fluids like ketchup become easier to pour when shaken because their viscosity drops with shear? Others, like quicksand, act solid until disturbed, showing how these fluids can blur the line between liquids and solids. This makes handling them in large quantities a fascinating challenge. In essence, scaling non-Newtonian fluids for industry is about understanding their unique flow traits, designing equipment that adapts to those traits, and continuously monitoring the process. It's a careful balance of science and engineering that helps turn these odd fluids into useful products on a large scale.